Good morning, good afternoon, good evening, good whatever it is wherever you are today. I'm Ali Almagasu, I have hair in my face, and I'm welcoming you to the latest episode of Cloud Unfiltered. Today we are really excited because we have someone on who is very well known in cloud communities. He's been on every stage I can think of, at every conference I can think of, and we've spoken to much of his staff on episodes over the past year and a half. So we're thrilled to have him with us today. He is the Vice President and CTO of Cloud Computing at Cisco. Welcome, Lew Tucker.
Thank you very much. Great to be here.
And welcome, Pete. Always glad to sit down with you and talk.
You can't complain about having hair in your face when I'm sitting right here with almost no hair on top of my head at all, Ali. Come on.
You're right. That was thoughtless of me. I apologize. Oh, gosh. Lew, it's been a long time. And we're thrilled. And so we have so many questions. But I'm still going to put you through the traditional opening question. How did you get into tech?
Sure. Well, it's actually kind of interesting. When I left college, I first was a vice principal of an alternative high school. I did a little work in films. And then for about 9 or 10 years, I actually was at Cornell Medical School being a research scientist in neurobiology. But at that time, we were studying neurogenic control of hypertension, trying to understand the brain. And I got a lot more interested in how we could, basically with artificial intelligence, how we could start to use computers to understand neuronal functions and things like that. So I switched. I went back and I got a PhD in computer science and switched from neurobiology to computer science and moved to Boston, joined a company called Thinking Machines, which then was building massively parallel supercomputers, because at that time, this was in the early 70s, our computing power was quite limited. We had very big mainframes. The mini computers were just beginning. Microprocessors were coming out. So it was a very interesting time in terms of what you could do. So we assembled what was for a while the world's fastest machine, made up of 65,000 processors. And it was a machine to do everything from weather prediction to image understanding, machine vision, and I was largely doing machine vision at that time. My career moved on, and I went in with to Sun Microsystems as a part of the early Java team, where we saw an opportunity to create a whole new language and a new platform for writing applications. And then from there, I actually went into Salesforce and then back into Sun and eventually into Cisco, where I'm now doing cloud computing.
That is a wild ride.
Yes.
And I think it's really encouraging, actually, because I think there's a lot of people who look at tech and they think, that seems like a really exciting, interesting industry, but there's no way I can get into that. I'm already whatever I am. I'm a teacher. I'm a scientist. And you just said, I'm getting in. So.
Oh, yes. And it changes. And that's why you have to be willing. You have to actually embrace change, I think, more than anything else, because the innovation that's happening is just continuous. And it's continuing and going into new areas. So there's always new things to become interested in technology. If you have curiosity, if you're fascinated by this stuff, then tech is where you should be.
Right. Can't just get a degree and sit on it. You have to keep learning. I've definitely learned that. Hey, before we get into some of the questions that I warned you I was going to ask you about, I certainly used to see you at a lot of OpenStack summits. And I know OpenStack has a lot. It just had a release fairly recently, a new release, and there's always exciting developments going on there. Are you still involved in OpenStack? And
yes, very much so. I'm still vice chairman of the OpenStack Foundation. We still have a team working on OpenStack here at Cisco. And I think that, OpenStack to me represented a real change. I mean, if we look back in sort of the history of OpenStack, we had big public cloud providers, Amazon and everything coming out with these cloud platforms, but somebody who wanted to run their own cloud, they didn't know what to do. And so OpenStack, as fulfilled that need, providing a platform for anybody to essentially run their own cloud, public cloud inside their own data center and manage it themselves and be able to really now begin to explore what cloud computing would mean for their different businesses. So OpenStack is very much alive and well. I think that we're seeing it continue to grow, and particularly to expand in other parts of the world, which are now sort of beginning to have this uptake in cloud computing.
Yeah, I feel like in the beginning it was being promoted as kind of everything for everyone who needed a cloud. But now it's attracting a more narrow audience that is using it in enormous ways, though. Who's the right audience for OpenStack right now?
It's interesting. Initially, people, and this is where I think we saw some of the early issues, people were using OpenStack to try to compete with the major public cloud providers. And that turns out to be not just a software problem. That really is an operational problem. That's a scale problem. And so many people, other companies, HP, Cisco itself, we had forays into running our own public cloud platforms and had to pull back because I think the operational model is really an advantage that the large cloud providers have. But what's interesting, I think that OpenStack started to move then, and I know that actually in India and in Asia, there are large cloud providers now running OpenStack. But most particularly and particularly from Cisco's point of view, we saw an opportunity here in this world of NFV for network function virtualization as we're moving to things such as mobile packet core. So a lot of the network services now are becoming virtualized. And so many of the large telcos now are using OpenStack as their virtualization platform for their virtualized network functions and mobility, mobile packet core, and other kinds of things. And that's where Cisco actually has quite a good business as well.
You know, I'd like to have some of the PTLs on from projects that were, updated in this most recent release and get deep into the details. But just off the top of your head, what were kind of some of the most exciting things about the most recent release of OpenStack?
I think, we're seeing actually the different things happening. Again, when we have these different technology shifts that are happening. So containers, for example, and like Kata containers that are coming in that we're seeing. OpenStack, we really are expanding to be more about open infrastructure. So Zool and things like that. So how do you manage and how do you orchestrate the deployment of virtualized infrastructure? With the containers also, we're seeing people who are running containers on top of OpenStack. They're running also on top of bare metal, using Ironic to do the deployment. So we're seeing the sort of convergence of different models, whether it be virtual machines or whether it be Kubernetes containers, being available to people who are running now on top of OpenStack.
Neat. Okay, I'll let you diverge from just talking about OpenStack and get to what is curious to me is, as you said at the beginning of this, innovation keeps coming. From your seat, what's the most interesting development in cloud computing right now?
Well, I think we're seeing a big shift, and actually this is being driven a lot by what we see going on in CNCF, for example. Open source is actually, I think, the largest, is having the biggest change on cloud computing today. The use of open source in applications that are running on top of cloud computing and in the cloud computing environment itself. So I think that the number of projects now that are going into CNCF are very, very interesting. And obviously Kubernetes is becoming a real foundational platform for that. And when we think about it, if you step back for a bit, and since I do have a long history in technology, I tend to try to look and see that these different abstraction levels that we have coming out now. So what we had first was virtual machines. And virtual machines were great because you could stack many machines now on a physical machine. And you could spin up virtual machines and shut them down. It was software controlled infrastructure. You could do that with virtual machines. But you brought around the whole operating system with it and everything else. So you were emulating the physical processor, the physical machine itself. Another abstraction though that came out of the Linux world was being able to separate applications through something called namespaces, where you can isolate resources that an application has, but they could still share many of the same underlying operating system functions and everything else. So now you had a much lighter weight abstraction layer, which could allow multiple applications to run on the same machine or the same node, and have some separation between them so that you're not as interfering between those two. What we had to do then at the same time, and where containers came from, was this notion of isolated resources, but also now how do you package up all of the dependencies? So from a developer's point of view, and this goes back even to the early Java days, we wanted a write once, run anywhere concept. And we were trying to do that with the Java virtual machine. Now we can do that essentially with Docker containers and Kubernetes. so that we have a way of packaging up applications in a very, very light format. They can be spun up in a matter of seconds, and they can fit multiple containers on the same machine. So you have another layer of abstraction now for people to start to work with as they're packaging up their applications. And Kubernetes takes care of then a lot of the deployment issues, because with Kubernetes, that's an orchestration system for containers. And that allows developers to explicitly state, I would like to see 3 instances of this application running for redundancy purposes, and Kubernetes will take care of that. And it will make sure that that happens, so that scheduling and everything else and orchestrating of the containers is handled now by Kubernetes. So that I find, again, a different abstraction. Every time we do this, we're making it easier and easier and easier for the developers to develop applications. And they can be run in any language that they want. So we have, I think, real advances going on, which is going to accelerate application development. And so that's why I think that that's interesting. And then maybe later we can talk about Istio and some other things that are also coming along in that same realm.
Okay. So if open source and the resulting container projects and all that is the most interesting thing going on in general in cloud right now, what about Cisco? What is Cisco doing in relation to cloud without making it too much of a Cisco commercial?
I think at Cisco is that it is a world of multiple clouds, many clouds, and that we have, a strategy around the fact that most of our customers now are running applications in their data center, but they also have applications running in one or more public clouds. And all of a sudden, something that became simple now became really hard, because you have, them being spread across different policies, and how do you manage identity and user sign-ins, and what are the services? And you might want to take this one service from one cloud and another service from another. So we have sort of wrapping these things up into a multi-cloud strategy, whereby Cisco can provide a lot of the networking infrastructure and security and identity management and all of those things necessary around it to allow companies to connect their data centers to public clouds. And so that we announced relationships with Google, for example, allowing essentially the connecting up of a data center with Google services and being able to run then in the data center. We have a Cisco container platform that allows people to run Kubernetes in their data center, and now they can have the same environment in their data center as they do in a public cloud running Kubernetes.
That is exciting stuff. Pete, I know I've been hogging the conversation, and I bet you have questions for Lew.
But I don't know if either of you are aware of this, but whenever someone mentions Cisco Container Platform, I am now required to point out that it's the only GKE certified Kubernetes distribution on the planet right now, outside of what you can run natively on Google.
Well, thank you for mentioning that. You carry your burden gracefully.
I do. Lew's boss reminded me of that yesterday in a meeting, so I had to make sure to get that in. I want to sort of double click on one of the things you were talking about, Lew, with abstractions, because I remember in the mid to late 90s having knocked down, drag out arguments with the IT ops guys about even JVMs and the layer, because right before that we were running you're running programs written in C or COBOL or some lower level language, and they were running on the bare metal. And there were worries that if you abstracted that into the JVM, that you're going to get the benefit of write once, run anywhere, but now you're introducing some performance overhead. Yep. So now if we take some of those things that you just talked about a minute ago, suppose I have a piece of Java code that's going to run on a JVM, and now I'm going to package it in kind of inside of a container. And in some of those different iterations, that container might run on a shared VM. The Kana approach is that container is going to run on, each pod gets its own VM, is one of the ways that they kind of structure that. Other folks are saying, well, we need to get this to a point where that container is running on bare metal so that you don't have to pay that VM tax anymore. What are some of your thoughts because you've seen these abstraction games even longer than I have. What are your thoughts on like pluses and minuses and where you think that might eventually settle? Like in 5 years, in 5 years, are we going to see everybody's, of course, everyone will be running containers on bare metal and nobody will be running on VMs anymore. Like, how do you see that shaking out?
Well, I think they each have their role to play. For example, some of the different things that are years ago, back when we talked earlier, like where did I start in technology? That was assembly language programming.
Yeah.
IBM 365. And everybody said, oh, you'll never get a compiler to be as efficient as it is, as I could hand code this. And even when I was working on a connection machine, writing some very low level microcode, that was very much in a communications layer, very specialized function. The rest of the time we want compilers got you 98% of efficiency or whatever. There was no reason not to use high level languages. You could write code much faster. And you could actually, when you move up a layer in abstraction, you actually think about things differently and you can do things differently. So I'm not so sure we're going to see everything just go, and actually bare metal is a misnomer. It's really not bare metal. We really have bare metal. We've got servers and then we have operating systems.
Right.
And what we've been writing is running JVMs or applications directly on top of operating systems, whether it be Solaris or Linux or anything else.
So what you're saying is if you started with microcomputers, your definition of bare metal is very different.
It's very different. Yeah, exactly right. And actually some of that code now is actually kind of moving to smarter NICs and things like that as well. But these abstractions are important because I think it's about how quickly can we develop applications. And as the bigger trend I see moving towards is much more of an assembly of services model for how we're building applications. Writing a full application yourself from everything through your graphics libraries and UI libraries and everything else. Nobody does that. We depend upon other libraries to provide most of the functionality and that we're writing more of the control logic and the business logic above it. When we look forward again, one step into the future, more and more we'll be assembling, an application will become an assembly of services. And so I might use a big data service from a cloud provider. I might use an AI system service or whatever to do voice translation so that we will be able to use voice as a part of the application. And not everybody's going to build that into their application. They're going to use some other service. And then you want an e-commerce service. You want, a calendaring service for appointments. So it's interesting. I was at Salesforce's Dreamforce conference yesterday, and they started talking about how they're using AI. And I think where they're using AI is now making it easier so that a sales rep, either preparing for a meeting, can simply talk. They have now a voice input, so they can talk and say, show me the briefing on this. And after it, they can say, set up an appointment, a follow-up. We start to have a conversation with applications. And so when we start having a conversation with applications, that means that application has to reach out into all of these different services to do what its function is. That, I think, will be the biggest shift going forward.
Well, and somewhere Gene Roddenberry smiles at that, right?
I think so. I think so.
Well, now let me ask you this. So the argument you're making towards, really, you're making a developer productivity argument.
Yes.
And
the expense and the new possibilities you can do when you're not having to write it all yourself.
Right, exactly. So let me throw a couple of stats at you and let me see how you react to a couple of these things. So Stack Overflow, which is kind of the the lifeblood of being a developer, and it's so much easier to become a developer, to Ali's point earlier, because it used to be if you didn't know how to do something, you had to have a friend smarter than you that you could ask, right? And I mean, what Stack Overflow has done has become the, I copy and paste my error message or what it is I'm trying to do. And you find somebody else who's asked that question and some expert who's answered it. So Stack Overflow does a user survey every year, and they published that in the spring. And this most recent one of the questions they asked is, how many years has it been since you learned to code? And I found those stats particularly enlightening because they had over 93,000 people respond to the survey, and 36% of them had learned to code in the last 5 years, 55% of them in the last 8 years, And old timers like you and me, I was in the top 4% at 30 plus. I wrote my first line of code in BASIC on a TSR-80 color computer. Right. And so you talk about sort of these waves of innovations and that really they create this catalyst for disruptions in different industries is ultimately how that manifests itself. But the churn and how quickly these things change can be difficult for a developer to keep up with. So I guess let me ask, are you seeing any trends with, is it someone who's in that 30 years plus bin like you and I are that has trouble keeping up with that change? Or is it easier for us because we've seen so many already? Is it harder for the younger folks in that set to sort of keep up with the change because they just learned something and now all of a sudden you're changing it? Or is it because they're younger, they're kind of more adept at change? Like what are you seeing in those extremes?
You know, it may be because of my age that I think experience matters. So when I try to now learn yet another new language, and there will be 2 years from now, I mean, now I've been playing around mostly with, it used to be Python and now Go, and I'm sure 2 years from now it will be something else. It becomes easier and easier. And you do have to give up. I used to love to program in Lisp. I thought Lisp was a fantastic way to think about algorithms and problems and everything else, but I would never code in it today. So I think that for the advantage the old timers have is in fact that they have seen this before and they already know 1 or 2 languages. And we know that once you know 1 or 2 computer languages, it's easier to learn a 3rd or a 4th. It does take retraining. It does take, you have to step back and you have to say, geez, I'm not done with school yet.
Yeah.
And fortunately, what we have is the world's best learning environment in the web. I mean, you can go online tutorials. I'm almost always getting new tutorials for something that I want to learn about. There's Udacity. There's great online services that allow you to come up with your skills. And then there's also increasingly tools so that, for example, in the world of AI, not everybody, AI, the deep algorithms in AI require really advanced mathematics. And yet that isn't needed now to use AI because these things can be encapsulated into services and into frameworks. And so the people now don't necessarily have to be a data scientist. They can be a domain expert in one area and they can start to use these other components. So back to this notion that what we really are doing is that we are assemblers of services as delivering an application. It becomes much more important to have a clear idea of what you're trying to accomplish. And then you might use a variety of different languages or different services to accomplish that. And so I think that whether you're new to technology or only been programming for 4 years or you've been programming for 30 years, the ability to adapt and to learn new things is the most valuable skill you can have. And I don't think that's age related. I think we all have the ability to learn.
Right. Well, and that's to what Ali was speaking to earlier. I don't think it's ever too late to get started to learn a programming language. And like we've said, it's so much easier to get on board with that now. You see organizations like Girls Who Code, or there's another organization I've seen recently is Moms Who Code. And it's just groups of people going through the learning curve together and kind of learning from each other's mistakes and advancing themselves that much more quickly.
As you guys talk about these different languages and the change, I know on a recent episode, Pete and another guest were talking about how there's certain languages that make it easier to understand serverless because you think in terms of events, right? And there's certain that don't. So it makes me wonder, are there certain programming languages that you feel right now would be most valuable to know in order to move forward and grasp whatever's coming next? Are there certain kind of core?
Yeah, I think there are. I think that we are seeing, we've gone through periods where we've seen, like when Java came out, Java was like the new language, and as opposed to C and Fortran that was still being used.
Yeah.
And we thought there was going to be consolidation around the single programming language. And then we got Scala. I mean, then we saw an explosion again, Cambrian explosion of language species or whatever. And that is because I think that, as Ali, as you mentioned, some are better for some things, and event-driven programming or whatever is much better using Node or any of these other languages that are easiest to work with. in terms of serverless is an event-driven kind of paradigm. Scala had other properties in terms of being able to scale. So what we have, and then if you're talking about mobile, if you're a mobile app developer, then you're generally using the tool sets associated. That becomes just as important as the language, the tool set that you're using to create UIs and to be able to package up your application for mobile deployments. So we are seeing a specialization, I think, according to where the application is going to sit.
Okay, so there's not just one or two that would really equip you for moving forward better than others.
I think there's general languages in terms of like knowing Python, knowing Node.js is important. Go if you're actually much more in kind of cloud native application areas. But then it's also like, how do you put these things together? So that's where things such as Istio and other kinds of things have a different paradigm for how you're connecting up services together.
Oh, well, I know we wanted to talk about Istio. PTO specific questions about that?
Well, so you've kind of brought up this concept of assembly of services, and there's a couple different, and really that's part of what's led us down, this microservices design pattern that we didn't always have before, because it used to be the networking was so poor between physical or even virtual machines, right? It didn't behoove you from all kinds of perspectives to have these little components that expose themselves over REST APIs that, you could abstract detail as to what programming language it was written in or whatever. We didn't used to have that. And that's part of what's led to this. So Istio is one of the things that kind of promises to help us manage this assembly of services by making it easier to discover them wherever they might be. But as we were talking in prep for starting the recording, right, you see this pattern that happens with open source where, somebody has a great idea and starts it, and they get maybe a couple dozen people eventually to help them start to work on it. And it works great for those couple of dozen people that are contributing it. But if you're somebody who's outside, I don't want to contribute to it. I just want to learn how to use it. There's typically, when those things kind of start off, there's a gap in documentation or training materials for that. And then there's typically a second gap with, okay, now I understand how to use it. Now I want to tell other people about it. And then there's this gap between sort of the technical documentation and the marketing. Mm-hmm. And it feels like with Istio, we're somewhere in between one of those two gaps. So as obviously, you play a big role in that world as a member of the board of directors for the CNCF. What's your definition of Istio, and what are the benefits that it
Sure. Well, a couple of things, because I would actually take issue with that. In open source, you have to be a contributor to understand it. I think it's absolutely true, as you say, the documentation and examples sometimes lag behind the code.
They do.
So the best way to maybe know it is to know the code, but it doesn't necessarily mean you have to become a core contributor. But I do think that in the where Istio, I think, fits, and maybe between kind of three things that are going on here. So we've seen containers, Docker containers, as a way of packaging up applications and spinning them up really quickly. Kubernetes is for orchestrating containers, how you deploy them, how you keep multiple replicates running in pods, and you've got clusters of these services. Microservices architecture says you want to create very, very simple services, and then you connect them up. So the services themselves should do one thing very well, and that's it. And then you can have Kubernetes that can scale that up with load and everything else. Where I find Istio is to be particularly important is that that team that is developing that very simple service, let's say that service is for a registry of user profiles, or another service might be a e-commerce system that allows you to order things. Those teams shouldn't have to know all of the networking that you mentioned that can be so complicated. They don't want to know about circuit breakers. They don't want to know how they do A/B deployments, or they don't want canary deployments. What do they do with their logs? How do they manage it? So Istio offloads all of that communications, all the issues associated with communications and observability and the telemetry associated with that, into the service mesh. But now the operators can actually look at that service mesh, and they can actually tell what's going on in the applications. That means that the development team that's doing a particular microservice doesn't have to know about that. They're just writing essentially to localhost.
Right.
And so, but now the rest of the mesh takes care of the communication. So that that incorporates security, that incorporates key management. All of these other issues are offloaded into Istio. So I see Kubernetes for orchestrating containers, and I see Istio as orchestrating the communication between microservices. And as you mentioned, we're moving now also into a world of serverless. Well, serverless is really the same model, very, very simple functions now that need to communicate. And so I think that we're starting to see also Istio having a role there in this world of serverless application development as well.
Well, we didn't warn you of this, but you've just played the Cloud Unfiltered drinking game. That when you use the word serverless, if you're listening, you have to take a drink. So if you opened that door,
can it be coffee?
Yeah, now that you've opened that door, Pete's going to rush right through it.
I'm going to jump through it. So, yeah, I mean, I agree with you that, all open source products, you don't necessarily have to be a contributor to take part. But I think there is a life cycle in open source projects such that, in sort of the toddler phase, only the contributors can figure out how to make it work. And then in the adolescence phase, somebody writes some good documentation that people who aren't contributing can play with it and file issues. And then there's a later phase where a marketing guy gets a hold of it. And you can start doing more broad communication of what the benefits are. And so Istio is rapidly approaching that. But another that is not quite there yet, which I think we've both, based on other conversations you and I think that it's a place to go, is if you think of Kubernetes as like an operational platform, you could do some cool things on top of that, like Kubeflow, for example. Mm-hmm. But then you could also do, there's currently 5 open source function as a service runtimes that are installable on top of Kubernetes. And this has been my sort of my summer research project has been to install all of them individually on top of Cisco Container Platform, and then to try to build the same application on top of all 5 to see what that experience is like and what are some of the pluses and minuses of the different approaches. Mostly function as service runtimes and serverless has been sort of touted with the public cloud variants of that, whether that's Lambda, Google Cloud Functions, or whatever. But do you see a future for maybe 1 or 2 of these 5 to emerge as there's going to be a ton of use cases where we can abstract this up to just give me some library of functions that's how you execute this assembly of services. But since it's all on top of Kubernetes, now I can run it. I could run it on a public cloud if I wanted to. I could run it on my private data center, or maybe I could run some of them, on my router that has a KVM plane on it, or those kinds of things. Is that, how viable a direction do you think that is?
I think it's very viable. I do think there will be multiple flavors. I think, again, serverless, which is essentially, or functions as a service, which is a better way to describe it. We still have servers, is event-driven programming. And if we go back actually into the previous, generations of data flow and things like that, that's the big shift in towards of event-driven programming. So I expect for a while we will see multiple approaches, multiple platforms, each of which will be emphasizing and doing different parts of that paradigm that is important. And we're seeing, for example, Lambda and Amazon and Google, everybody will actually start competing again for that platform space in serverless. What I think the beauty of open source is in this whole world, though, has been, we want this to be essentially have developers vote with their feet. Right. And so that we want to have the ones that emerge not because of a particular market dominance or whatever, but rather a developer attraction.
Yeah.
So that, and I gave a talk years ago actually about this whole notion that the collaboration that we have in open source is what is making it so that these different platforms can spread very rapidly. And developers all they really have to know is GitHub. And with GitHub, they can actually go and they can get this. And just like you're trying these different platforms with the same application. So you can make your own judgment. And I think you should be able to, you said it's a weekend or week project or whatever. Yeah, I think in a short period of time, you can go through these things and evaluate them. Now you're making your choice for what's best for your business or the company that you're working with. That's very, very different than in the old days where you might have had to install a huge application, Oracle Financials or SAP, months and months and months of development and big consulting services before you even know whether you have the right platform.
You used to be able, you used to have to make, am I doing this with Java or .NET? You used to have that, you used to have to make that decision before you ordered the hardware,
right?
Let alone start like the design documentation back in the waterfall days, right? It's
yeah. So I think we are in like sort of the golden age of developer and platforms, and tied in with the internet and everything that was happening as the internet continues to evolve and change, as things much more become into devices and IoT and things. That is, the developers now have a huge potpourri of tools that they can start to use, and they are lightweight enough that they can quickly get evaluated, and so they can make their decision before they go and they build out huge deployments.
Well, and even the turnaround time, this came up on an earlier episode. It's okay to spend 5 developers' time a month building something and then throw it away 3 months.
Absolutely. You have to be willing to do that, and that is well spent.
And it's not like that same legacy model where we had these monolithic applications, and like I said a minute ago, where you had to make platform choices like
long in advance
before it was going to appear in production.
Exactly right.
Now, the last sort of technical thing I wanted to make sure to get in a little more detail on. The last time you and I saw each other face to face was at Cisco's AI Day, where we had a bunch of folks internally kind of talking about the different AI projects that were going on. And I co-presented with one of the gentlemen that works for you, talking about my part was public cloud status, state of the public cloud of AI in the public cloud. And you have some folks who are looking at Kubeflow. So again, back to this idea is you start at Kubernetes as your operational platform and sort of build from there. What's going on in that space that people should know about?
Yeah, I think again, it comes back to this notion that Kubeflow is really, I don't know what to call it, a platform, a framework. It's an assembly of a lot of the basic ML, machine learning, AI algorithms and components, so that people can start to explore whether AI even makes sense for their problem.
Right.
Years ago, you don't want to spend a whole lot of time with, there's different kinds of algorithms developing too deeply until you get some idea. You have to do this iteration with collecting data sets and having models and being able to compare different models, because these systems perform quite differently depending upon what is the basic model underneath.
Sure.
Kubeflow or TensorFlow or any of these other models. So Kubeflow is really meant to make that easier for people. And as we start to standardize on that model, we also then have an advantage, because then we can start to have third-party benchmarking done.
Right.
So the other thing that we want to be able to do is that back in the supercomputer era, whatever, we had standardized benchmarks, so people could really compare one machine, one language with another, and you can make and they were published. So I want to see us. There's other things that I'm excited by. So there's open source. I believe in open data. So I'd like to see more and more very large data sets made available for people to run algorithms, particularly AI algorithms, against, so you can compare results, and being able to then express all of these things, even with other tools such as Jupyter Notebooks. I was playing around with Jupyter Notebooks to go through a lot of these different AI paradigms, whatever. That's a tremendous learning tool. And so I think that these frameworks and platforms and tools such as Jupyter Notebooks allow people to learn. That means they can start to use AI without becoming an AI expert. They don't have to know all of the mathematics behind it. They can start to use these components and do the testing and learn that way.
Yeah, very cool. That has the potential to take off there as well for all the other. It flattens the learning curve, right, and makes puts a premium on developer productivity in a way that even at that AI Day talk I mentioned Watson, right? And if you go back to even doing Watson, let alone like the chess building, the chess system that defeated Kasparov in the 90s, like that stuff was so. I mean, that stuff you had to get down into like C and assembler in order to, and you had to have the right hardware. And we've got so many different layers of abstraction now that we didn't have before that just make these possibilities seemingly endless.
And this is where I think it's not just developers. So product managers or product management, or when you're really designing what should this service do or what should this application do, I think that everybody needs to become educated about what AI is good at today and what it's not good at. It really is very good at classification, categorization, recommendations, pattern matching. These things are pretty well understood, and they can be used pretty directly in almost all applications today. So I think that business leaders and product managers and product owners really need to know enough of AI so that they can start to see these things. And that's where the developer's role becomes one of being an educator internally within the company, as saying, here's a prototype I did. And yes, make that 5-day investment to learn what is possible and get a proof of concept going. That's the best way to educate your business leaders.
Yeah.
I think it's interesting that you brought up the developer's role, because mostly we position it as the job of the IT leaders and business leaders to chase down the developers and either try to prevent them from doing things they don't want them doing, or to find some way to corral them. And so that's interesting. So that some of the onus should be on developers to kind of be bubbling up these ideas.
It has to be. I mean, I think that we are closest to the technology, and it's incumbent upon us to inform our leaders and everything else about what is possible.
Well, it brings up an interesting question. I mean, if I'm an IT leader or a business leader listening to this right now, and I know, because if I'm that person, I'm dealing with it in my daily life. There are these waves of innovation that are crashing over me and my company. I do have developers voting with their feet for different technologies. How do I get my hands around it? What would be the single kind of tip you could provide?
Schedule demo days.
Schedule demo days.
Demo days. I mean, that any development team should always have demo days, and I think that the leadership and business leaders should attend, and they should see. And that, for example, one of the things that I've done at Cisco, we've brought in a large number of interns, and we've done this with international interns. They would come in for a year at Cisco, and the first thing I always tell them is that, okay, you come in, we get you situated and everything else like that. And now what I want to see, like in 6 to 8 weeks, I want to see a demo. Whatever you want to do.
Yeah.
Demo something for me. Build it, show it off to me, and then we'll have the conversation. Before they get assigned to a project, or they're told they're doing this or they're doing that, let's see what they can do and what they can come up with. They'll start to learn, they'll have conversations with their peers and everything else about what are the larger, things that they're a part of. But they start learning that building. It's all about building, and that I show up to see it. So this is a mistake I think that a lot of executives make, is that they don't show up. They want to get it filtered through their management chain instead of having the individual developers showcase their work. So
they need to see that passion that those developers have for that particular language or that product or that solution. I think that's really an interesting way to kind of bubble up. It would help keep you close to the edge of what's new, because the developers know.
Well, and you don't have to look any further than Gmail to find a good example of where something like that turned out.
Exactly right.
Right. I mean, over half the planet uses an application that nobody asked for, that some developer thought, hey, we can do this a better way.
Yeah. And I'm sure if you looked at even, the disruptions that are happening now in each of the different businesses is so extreme that you're seeing, Uber, changing the way, transportation is done through an app. Then sort of the business model around how you connect up drivers with customers and everything was done. But it sort of was the app that came first. And we saw it like with Netflix delivering, movies instead of by Blockbuster videos or whatever over the internet. These things start with apps. And I'm sure each one of them started. I remember actually at Salesforce developing the App Exchange. in a couple of weeks or a month or so with one other developer, and showing it to Mark Benioff, say, we could have a marketplace for our online applications. And this was at the time, I think iTunes was the only place, and that was my analogy. Just like a song, why not make an app as easy as to download as it is a song? And so we demoed it, and then Mark bought into it and goes, "Grow, let's go it. We're going to go with this."
Oh, that's wild. So demo days are the way to do it right. My last question for you will be, what's the way to do it wrong? What's the mistake you see IT and business leaders making when they're trying to help move things forward and embrace these new technologies? Where are they getting in their own way?
It's a cliche, but I don't know. So I don't know how to, but, if we're constantly avoiding risk, if we don't let developers fail, if we don't let, proof of concept, you spend a couple of weeks developing it and you decide, no, that's just not it. And that we have to embrace letting things fail so that you can find things that are really good. And I think we financially and everything else in our institutions, we are like cutting it too close. We're not giving enough latitude for there to be experimentation, because in that experimentation, I think, is where the next big changes are going to come from.
Yeah, bravo.
We can't just guide this, through a top-down kind of thing. We have to let the experimentation. So give developers more time for them to show what they can do. But that's why, to make it accountable, make sure that we're always looking to see what they're doing.
I love it. That is a great piece of advice to close on. Thank you so much for being with us today, Lew. It has been very insightful. I really appreciate the things you shared, and I hope you'll come back and visit us on a regular basis, because I know there's a lot of interesting things going on that you have your hands in. That I don't know how you possibly have your hands in so many things at once and sleep at night, but we do appreciate it. So
well, thank you so much. Been a pleasure.
All right. Bye-bye. Bye, Pete.
Bye.